let us begin with that. So this is question number 22. Okay. So this is IIT JAM 2021 math paper, of course, and question number 22. Okay. So this question is just purely on matrices. So let us see. So we have an invertible matrix and we have a nilpotent matrix. So first of all, we have this nilpotent matrix. So Rohan, do you know the definition of a nilpotent matrix?
So I'm not aware of nilpotent matrix much.
Okay. So what anyone knows? What is nilpotent matrix?
If A is a matrix, then there exists an n belongs to the natural number such that A to the power n will be 0.
Right. So we did nilpotents, right? I think even in rings we give some questions on nilpotents. Maybe, yeah. I think we did. So anyway, so nilpotent matrix is fine, right? So there is an n such that A to the power n is equal to 0. This is probably all you need to know for this question. Okay? So there is an n such that A to the power n is the 0 matrix. Okay. So for this, the characteristic polynomial is x to the power n. Okay, you can say it in terms of characteristic polynomial also. So nilpotent matrix definition is fine. Now we'll write the question. So A is n by n invertible. So A is an invertible matrix. Nilpotent matrix, we discussed some questions earlier also. And C be nilpotent, n by n nilpotent. And then X is this matrix, where these xi's are also matrices. So the matrix of matrices and this whole thing is 2n cross 2n, and xij, this is n cross n. And then there is a commuting condition. The x commute with p, which is also defined again in terms of this block. So just think of this as block matrix. Okay, this is the n by n part, and this is another n by n part together there. And this is a special block matrix, like right. So basically, let us see which xij is necessarily 0. Okay, there are some options, but all this will follow if you try to answer this. Let us see rings for the first time as well. So I would hope that you have tried this question, okay, because that was told to try them, but it's fine. Let's try it now. So let us just try to write down what the commutativity implies. X commutes with B. Let's just write it and see what it implies. So we will just multiply them. And here we will invoke the multiplication rule for block matrices. everything is square matrix, so you don't have to worry anything about expressions or any formula that works will work in this case. Yeah, I've written it the other way. So just multiply it like you multiply matrices. But you have to just be careful with this. Like you cannot write A x11 as x11A. You cannot do that anymore. Okay. That you cannot do. And also, if there were three matrices, then associativity, I am not completely sure. But this, which what we are doing, this you can do. Okay, let's do it fast. So what can we say from here? So you can compare the terms.
Is the answer is x11 and x22 are necessarily 0?
Yeah, that is in the option, but why is that? Can you tell?
Because if x commutes with b, we can clearly see that x11a, x12c means the last matrix we have. We got that x11a, x12c, and x21a and x22c, that will be only equal to the previous one if a and c are 0.
Which ones? X11A and this two, this has to be equal to this.
Yeah.
Okay. Okay.
A and C are the scalar multiple of the identity matrix.
Why?
Because A okay, let me think something else.
Yes.
Is my correct answer is correct or not?
I don't know. But I mean, if you give a proof, then it's correct. Yeah, otherwise it's still there.
Okay.
I am getting something different, but please continue to try. I am getting x12 and x21 are.
Uh,
Huh?
so what if?
Yeah.
So we have. Okay, 1 second. So I'll just check my.
So Arnab, I think Arnab
So
said that, yeah, Arjun, go on.
yes, sir. So if we have a x12 is equal to x12c, then we can multiply both sides of the equation by c to the power k minus 1, where c to the power k is 0.
In this,
Because it's yes, sir.
okay. You multiply both sides by c to the power k minus. Okay,
So then you'll get a x12 c to the power k minus 1 is 0.
right. So ax
Yes,
one
sir.
two c to the power k minus 1 is equal to 0. Nice.
And then we can multiply by the inverse of a, but after that, I don't know what to do.
Right. So you are basically getting this.
Yes. And we know that c to the power k minus 1 is non-zero because
Good.
k is, I'm
Yeah.
taking it as the
Right.
least.
Yes. Yes.
Yes.
Yes. Right. So you can basically use this idea, right? You can basically use this idea. So I think Arnab said that C is 0. Arnab, did you say C is 0 at one point? No?
C. Sorry, I have not heard. But okay, C. But
Maybe, I don't know. Anyways, yeah, even if you forget, it's not a problem. See, the point is you can assume that C is 0. Just think.
actually, I was thinking that the equation x11 ax11 equal to x11a and the equation c x22 equal to x22c. We can write it as x11 minus x11a equal to 0, and C
Wait,
x22
x11 minus x11a.
yeah equal to 0.
Why?
They are giving their matrices, so we 0 matrices.
But what is equal to 0? Ax, this is equal to 0, right?
Yeah.
Okay, sorry
I'm just
then.
taking the right. Yeah, that
ठीक
is
है
equal
फिर?
to 0, and the last C x22 equal to x22 equal to C.
हाँ ठीक है then.
Okay, so these equations are look like the eigenvalue equations of A and C respectively.
Eigenvalue equation. What is an eigenvalue equation?
Eigenvalue equation is basically the if we take the vector A as some x0 and the vectors and the matrix C equal to 0 y in column vector column matrices,
Okay.
and then if we do it like multiply them and then do minus, that will be look like the eigenvalue equation.
Eigenvalue equation. Okay. Yeah, but this it still it doesn't look. Yeah, maybe you should explain a bit more. But yeah. Anyway, see, the point is that you should again you have to think of it from the angle of abstract algebra. Otherwise, you will end up in a mess. Means you will keep thinking and doing some tricks. Why don't you see it from the angle of abstract algebra? So you know that this thing means that something is in the center of something. Center, center of a ring. Yeah, maybe you don't know that, right? So let me just put it simply. You see, if you have this equation, this is a very powerful equation, right? If you have this equation, multiply both sides on B, you get this. Right? So it means that B square also commutes with X. B cube also commutes with X. B plus B square will also commute with X. Fine. Everybody sees that? It's a plain simple, right? So basically I'm saying that that's a definition of center, which you don't need to do the problem, but it's good to know. So center, so everything is happening in M and R, right? So you have to go outside the two matrices that are given, A and whatever X and A, to understand that nicely. And you can see that it's sort of necessary. Center of anything is basically all the maybe I will just say it in the next board abstractly, and then you will apply it here. So R be a ring, it's useless in a no, not you. Yeah, R be a ring. You know what, right? And A be an element in R. See, it's you can do this problem with tricks. I know that, but just see, look at this. Okay, look at this. So A be in R. Then there is something called center, and this is a very important concept. If you've done group theory, also you would have studied this. Center of anything is what? It's basically the set of all C such that AC is equal to CA. Okay, and then center is a subring. That is easy. That's what the trick will tell you. That if something is there, B is there, then B square is there, then B plus B square, everything is there. The whole ring identity is obviously commute with everything, right? The center is there. Then basically now if you apply it to this problem, then you know that this commutes, right? So what does it mean? It means that what Aryan is saying, C to the power B to the power K. What is B to the power K? B to the power K is this. It means that this is also in the center, right? So it means that this will commute, right? But then if B to the power K is is commuting, then how to say? Yeah, I mean that becomes very simple. Okay, Yeah, I mean, okay, fine. Yeah, actually, no, but in this case, it becomes right. If b to the power k is commuting, then you can look at this matrix, which is you can look at this matrix. Maybe, yeah, maybe something. I mean, actually, this is enough, right? This is enough. This is enough, actually. Yeah, you don't have to go there. Just call this a dash 0, 0, 0. So basically, you have reduced the problem to saying that c is 0, right? Now apply, problem becomes very, very trivial, right? Come back to board 1. A is equal to identity, we are not able to assume, but c equal to 0, we are able to assume, correct? Now look, yeah, game is over, right? A
No,
x1
just
2 is 0.
repeat the last line again.
Which one?
Last line, whatever you say.
I'm saying that b to the power k will also commute, right? B to the power k will also commute with x. Is this correct or not?
Yes, 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 yes.
Right? It is just either you see from trick or you see directly from center. So now that basically means that c is equal to 0. That's how you use the nilpotency properly without going into okay, then compute the nth power and then some using properties we say. So now you just put 0 wherever x wherever so it's needed. Now it is done, right? So now a times x12 is equal to 0. A times x12 is equal to 0. Now you use that a is invertible. I mean, yeah, this a will become a prime, but it is still invertible. Power of invertible is invertible. The set of invertible things form a group. So a x12 is 0. This implies x12 is 0 because a is invertible. And similarly, x21 is 0. You can see, right? That's it. See, higher mathematics, it works like this because there are exponentially many ways, not a small thing. So you have to find the correct way to do the incise the attack the question. So you have to interpret this as a condition on the center. Please read center of a ring, center of a group. Very, very important subgroups or subrings. Okay, you can't miss them. Okay? Yeah, just read up center. That's all. Otherwise, you keep doing. It will maybe like what Irene was saying. From there, it will work actually. But you have to just do some. You have to apply it that c to the power k on different things, and then. But you can do directly. Yeah. Right. I don't think we can say that this. I don't think that we can say that this is there in the center. I am not able to get that. Yeah, that will be nice, but I don't think we can get that. Yeah, because these are not invertible matrices. I was going to do B inverse, but B inverse doesn't make sense. It's not invertible. All right, so the problem is done. It's simple. Yeah. So here your exercise would be to read on centers and to also read on block matrices from anywhere you want. A bit of it is there in Artin. Okay. And its Wikipedia page is also quite nice. And it will have some small reference. Look at the small 1 or 2 page notes kind of reference and read them. Block matrices are very important. Yeah. Yeah, so let me not expand on this topic right now. We'll move to the next problem after the break. Some other problem, which one would we do? Yeah, there is this one. Yeah, we'll do number 40. Okay, this is also in our port, I think. And try this problem. Try it in the break. Problem number 40. Okay, just Google IIT Jam. I mean, I can write the question, but there's not time. I mean, I have already sent you links. So IIT Jam 2021, question number 40. 40. Okay. All right, we'll meet after the break.
Yes, sir.